Welcome to G Fun Facts Online. Have you ever looked up at the sky during a drought and wished you could just make it rain? For over 70 years, scientists and engineers have been trying to do just that. It's a technology called cloud seeding, and it's one of the most fascinating and controversial ways we try to bend nature to our will. Today, we're diving deep into the science of how we try to make it rain, its surprisingly dramatic history, and the intense debate over whether it even works and what it might be doing to our environment. So how exactly do you give a cloud a nudge to release its water? At its core, cloud seeding doesn't create clouds out of thin air. Instead, it enhances a cloud's natural ability to produce rain or snow. Inside a cloud, water droplets or ice crystals need something to form around. These microscopic specks are called condensation or ice nuclei. Think of them as the tiny seeds from which raindrops or snowflakes grow. If a cloud doesn't have enough of these nuclei, it might just float by without ever releasing its moisture. Cloud seeding is the process of adding artificial nuclei to give these clouds a helping hand. The most common ingredient used is a chemical called silver iodide. Its crystalline structure is remarkably similar to ice, which tricks supercooled water in clouds into freezing at warmer temperatures than it normally would, kickstarting the process of forming snow. For even colder clouds, you can just drop in chunks of dry ice, frozen carbon dioxide, which is so cold it instantly freezes the surrounding moisture. In warmer clouds, where temperatures are above freezing, a different approach is needed. Here, operators use hygroscopic salts, like sodium chloride, basically table salt, or calcium chloride. These salts are fantastic at attracting water, pulling in moisture to form bigger and bigger droplets until they're heavy enough to fall as rain. Getting these materials into the clouds is an engineering challenge in itself. The most common method involves aircraft. Planes equipped with special flares fly directly through or above a target cloud, releasing the seeding agent. In mountainous areas, ground-based generators are often used. These are essentially big burners that release silver iodide particles, which are then carried up into the clouds by the natural wind currents flowing over the mountains. This is a popular method for increasing winter snowpack. Some countries even use rockets or artillery shells to deliver the payload with precision. And now, we're seeing the rise of drones and even lasers being explored as more targeted and cost-effective delivery systems. The history of this technology began with a happy accident. In July 1946, a scientist at General Electric named Vincent Schaefer was studying aircraft icing. He dropped a piece of dry ice into a lab freezer full of supercooled water vapor and was amazed to see a miniature cloud of ice crystals form before his eyes. He had just demonstrated the basic principle of cloud seeding. A short time later, his colleague, Dr. Bernard Vonnegut, identified silver iodide as an even better nucleating agent. Their first field experiment, Project Cirrus, in 1947, successfully used a bomber to drop dry ice into a cloud, causing it to snow. This set off a global surge in cloud seeding research and commercial operations, mostly aimed at helping farmers. But the technology took a dark turn during the Vietnam War. A secret U.S. military program called Operation Popeye used cloud seeding to try and extend the monsoon season over parts of Southeast Asia, hoping to disrupt enemy supply lines. The public revelation of this program was so shocking that it led to a 1977 international treaty, the Environmental Modification Convention, which banned using weather modification as a weapon of war. Despite the controversy, cloud seeding is used all over the world today for a variety of peaceful purposes. One of its primary applications is to increase water supplies. In mountainous regions like the western United States, cloud seeding programs aim to boost the winter snowpack. This snow acts as a massive natural reservoir, melting in the spring to fill rivers and reservoirs that supply water to cities and farms. In drought-stricken places like the United Arab Emirates, it's used to coax more rain from the sky. For agriculture, it can be used to suppress hail. By injecting a storm with a huge number of ice nuclei, The theory is that you'll create a lot of small, slushy hailstones instead of a few large, destructive ones. It's also used at airports to disperse fog, improving visibility for takeoffs and landings. And in a fascinating twist, it has even been used to try and clean the air. Before the 2008 Olympic Games, China used cloud seeding to induce rain over Beijing, hoping to wash pollutants out of the atmosphere. But this brings us to the biggest question of all. Does it actually work? After more than 70 years, the science is still hotly debated. The main problem is that weather is naturally chaotic. It's incredibly difficult to prove exactly how much rain a cloud would have produced if it hadn't been seeded. Proponents point to a growing body of evidence. Many studies suggest cloud seeding can increase precipitation by a modest 5 to 20% under the right conditions. A major study in Idaho in 2020, called the Snowy Project, used advanced radar to provide some of the clearest evidence to date that seeding does, in fact, enhance snowfall. Long-term projects in Nevada's mountains have also been shown to increase annual snowpack by about 10%. However, many scientists remain skeptical. They argue that the evidence is often circumstantial and lacks rigorous, repeatable proof. A 2010 study from Tel Aviv University, for example, concluded that cloud seeding had little to no effect on rainfall amounts. Just this year, in 2024, the U.S. Government Accountability Office noted that the benefits remain unproven. Critics also point out the obvious limitation: you need suitable clouds to seed in the first place. During severe droughts, when you need rain the most, the sky is often clear, making the technology useless. Beyond effectiveness, there are major environmental concerns, primarily focused on the use of silver iodide. Silver is a heavy metal and is toxic in high concentrations. So are we poisoning our environment to get a little more rain? The overwhelming consensus from numerous studies is that the risk is minimal. The concentrations of silver found in rain and snow from seeded storms are typically thousands of times lower than the limits set for drinking water. Silver iodide is also not very soluble in water, meaning it tends to bind to soil and isn't easily absorbed by plants or animals. Long-term monitoring in areas with decades of seeding hasn't shown a significant buildup of silver above natural background levels. But the book isn't completely closed. Some research suggests that repeated, long-term seeding in one area could have cumulative effects, and a few studies have found that silver iodide can affect some sensitive soil bacteria and phytoplankton. An even bigger concern for many is the idea of